According to the National Electrical Code, Section 400.7, in residential buildings and garages, all wiring installed in hollow spaces, such as walls and ceilings, must be in approved metallic raceways. These metallic raceways are commonly referred to as conduit. However, there are exceptions to this general rule. Specifically, NEC Section 400.3e allows wiring in concealed spaces in unfinished attics and crawl spaces to be installed in non-metallic raceways, such as NM cable, which stands for non-metallic sheath cable. Now, considering the application to hangars, hangars are generally considered concealed spaces within a residential building, so they are typically subject to the National Electrical Code requirement for wiring in metallic raceways, meaning conduit. This is the default assumption. However, there are some exceptions to the requirement for metal conduit in hangars under specific circumstances. One such exception may involve pre-engineered hangars. Some pre-engineered hangars may come with NM cable already installed from the factory. In these instances, it is imperative that the manufacturer's instructions are followed precisely regarding the electrical installation. These instructions will supersede the general rule, provided the hangar is installed and used in accordance with the manufacturer's listings and instructions. Another potential exception relates to unfinished hangars. Hangars that are not yet finished or insulated may be considered unfinished attics or crawl spaces for the purposes of electrical code interpretation. In these cases, NM cable may be permitted for wiring. It's crucial to remember that the determination of whether a hangar qualifies as an unfinished space is subject to the interpretation of the local building inspector. The recommendation is that it is always best practice to contact your local building inspector or a qualified electrical contractor to confirm the specific requirements for your fly-in community and residential home with an attached hangar. They will be able to make a determination based on all applicable factors and relevant electrical codes. The local authorities have the final say, and they will be able to determine definitively whether metal conduit is required in your specific hangar or if NM cable is acceptable based on the local interpretations and amendments to the National Electrical Code. Ignoring this step could be costly, as you may be forced to redo the wiring. Additionally, electrical installations must comply with the National Electrical Code, commonly referred to as the NEC, which sets the standard for safe electrical design, installation, and inspection to protect people and property from electrical hazards. The NEC is updated every 3 years, so staying current with the latest edition is essential for anyone involved in electrical work. The NEC isn't law itself, but it is widely adopted by states and municipalities for legally binding regulations. Now, metal conduit, such as electrical metallic tubing, commonly called EMT, rigid metal conduit, or RMC, and intermediate metal conduit, or INC, offers robust physical protection for conductors, shielding them from impact, moisture, and other environmental factors. It also provides a grounding path, enhancing safety by minimizing the risk of electrical shock. NM cable, on the other hand, is a type of electrical cable consisting of 2 or more insulated conductors wrapped within a non-metallic sheathing. It's commonly used in residential wiring for branch circuits, outlets, and lighting fixtures. NM cable is relatively easy to install and is generally more cost-effective than metal conduit. However, it's less resistant to physical damage and is not suitable for use in damp or hazardous locations unless specifically listed for such applications. When determining whether to use metal conduit or NM cable in a hangar, several factors must be considered. Firstly, local building codes and regulations must be adhered to. These codes may specify the type of wiring required in certain areas or under certain conditions. Always check with your local building department to ensure compliance. Secondly, the environment in the hangar must be assessed. If the hangar is subject to moisture, corrosive substances, or physical damage, metal conduit may be the better choice. Thirdly, the type of construction must be taken into account. In new construction, it may be easier to install metal conduit before the walls and ceilings are finished. In existing construction, NM cable may be a more practical option. Fourthly, cost is always a consideration. Metal conduit is typically more expensive than NM cable, both in terms of materials and labor. However, The added protection and safety it provides may outweigh the cost difference in certain situations. The National Electrical Code, as previously mentioned, provides detailed guidelines for electrical installations, including wiring methods, conductor sizes, overcurrent protection, and grounding. It's essential to consult the NEC to ensure that all electrical work complies with the code requirements. Section 300 of the NEC covers general requirements for wiring methods and materials, including the use of metal conduit and NM cable. It specifies where each type of wiring is permitted and provides guidelines for installation. Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. It specifies the types of boxes and fittings that are permitted for use with metal conduit and NM cable and provides guidelines for installation. Article 320 covers armored cable type AC, which is a type of cable that is similar to NM cable but has a metal armor for added protection. It specifies the uses permitted and not permitted for armored cable and provides guidelines for installation. Article 334 covers non-metallic sheet cable types NM, NMC, and NMS, which are the most common types of NM cable used in residential wiring. It specifies the uses permitted and not permitted for NM cable and provides guidelines for installation. Article 344 covers rigid metal conduit, which is a type of metal conduit that is typically made of steel or aluminum. It specifies the uses permitted and not permitted for rigid metal conduit and provides guidelines for installation. Article 348 covers electrical metallic tubing, which is a type of metal conduit that is typically made of steel or aluminum. It specifies the uses permitted and not permitted for electrical metallic tubing and provides guidelines for installation. In addition to the NEC, other standards and guidelines may be relevant to electrical installations in hangars. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, commonly called IEE, and the National Fire Protection Association, or NFPA. The IEE develops standards for electrical equipment and systems, while the NFPA develops standards for fire safety and prevention. It's important to be aware of these standards and guidelines and to follow them when designing and installing electrical systems in hangars. Grounding is a critical aspect of electrical safety. It provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors, the methods for connecting to ground, and the testing requirements. Proper grounding is essential for ensuring the safety of people and property. Overcurrent protection is another critical aspect of electrical safety. It protects electrical circuits from damage caused by excessive current, such as short circuits or overloads. The NEC specifies the requirements for overcurrent protection, including the size and type of circuit breakers and fuses, the location of overcurrent protection devices, and the testing requirements. Proper overcurrent protection is essential for preventing electrical fires and equipment damage. Electrical boxes and enclosures are used to protect electrical connections and devices. The NEC specifies the types of boxes and enclosures that are permitted for use in different locations and under different conditions. It also specifies the requirements for installing boxes and enclosures, including the size, location, and support requirements. Proper use of electrical boxes and enclosures is essential for ensuring the safety and reliability of electrical systems. Wiring methods refer to the way in which electrical conductors are installed and supported. The NEC specifies the types of wiring methods that are permitted for use in different locations and under different conditions. It also specifies the requirements for installing wiring, including the spacing, support, and protection requirements. Proper wiring methods are essential for ensuring the safety and reliability of electrical systems. Electrical safety is paramount when working with electricity. Always follow safe work practices, such as energizing circuits before working on them, using insulated tools, and wearing personal protective equipment. If you are not qualified to work on electrical systems, hire a licensed electrician. Electricity can be dangerous, so it's important to take precautions to protect yourself and others. When planning the electrical wiring for a hangar, consider the present and future needs. Ensure that there are sufficient outlets and circuits to accommodate existing equipment and any future additions. It's better to overestimate the electrical needs than to underestimate them, as it can be costly and inconvenient to add circuits later. Also, consider the specific requirements of the equipment that will be used in the hangar. Some equipment, such as welders and air compressors, may require dedicated circuits with higher amperage ratings. Ensure that the electrical system is designed to accommodate these requirements. Lighting is an important aspect of hangar design. Adequate lighting is essential for safety and productivity. Consider the type of lighting that is most appropriate for the hangar. Fluorescent lighting is energy efficient and provides good illumination, while LED lighting is even more energy efficient and has a longer lifespan. Also, consider the placement of lighting fixtures to ensure that all areas of the hangar are adequately lit. Proper maintenance is essential for ensuring the safety and reliability of electrical systems. Regularly inspect the electrical system for signs of damage or wear, such as cracked insulation, loose connections, or corroded terminals. Repair any problems promptly. Also, test the ground fault circuit interrupters, GFCIs, regularly to ensure that they are functioning properly. The NEC requires that GFCIs be installed in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electrical shock by detecting ground faults and interrupting the circuit. It's important to understand the different types of electrical circuits and their uses. Branch circuits supply power to individual outlets and lighting fixtures. Feeder circuits supply power to branch circuits. Service entrance conductors bring power from the utility company to the building. Each type of circuit has different requirements for conductor size, overcurrent protection, and grounding. Before starting any electrical work, it's essential to obtain the necessary permits from the local building department. Permits ensure that the electrical work complies with the building codes and regulations. The building department may also require inspections of the electrical work to ensure that it is done properly. Working without a permit can result in fines and delays. When hiring an electrical contractor, it's important to choose a licensed and qualified contractor. A licensed contractor has the necessary training and experience to perform electrical work safely and properly. Ask for references and check the contractor's license to ensure that it is valid. A qualified contractor will be familiar with the electrical codes and regulations and will be able to design and install an electrical system that meets your needs. Understanding electrical terms and definitions is essential for communicating effectively with electricians and other professionals. Some common electrical terms include volts, which measure the electrical potential difference, amps, which measure the electrical current, ohms, which measure the electrical resistance, watts, which measure the electrical power, and hertz, which measure the frequency of alternating current. Knowing these terms will help you understand how electrical systems work and how to troubleshoot problems. Electrical safety training is essential for anyone who works with electricity. Training courses are available from various organizations such as the National Safety Council and the Electrical Safety Foundation International. These courses cover topics such as electrical hazards, safe work practices, and first aid for electrical shock. Completing an electrical safety training course will help you protect yourself and others from electrical hazards. The NEC is a complex document that can be difficult to understand. However, there are many resources available to help you learn about the NEC. The NEC Handbook provides explanations and illustrations of the NEC requirements. There are also many online resources, such as websites, forums, and videos, that can provide information and guidance on the NEC. Taking the time to learn about the NEC will help you ensure that your electrical work complies with the code requirements. Electrical technology is constantly evolving. New products and technologies are being developed all the time. Staying up to date on the latest electrical technology can help you improve the efficiency, safety, and reliability of your electrical systems. Attend trade shows, read industry publications, and take continuing education courses to stay informed about the latest electrical technology. Troubleshooting electrical problems can be challenging, but there are some basic steps that you can follow to diagnose and repair problems. Firstly, identify the problem. Secondly, check the circuit breaker or fuse. Thirdly, test the circuit with a multimeter. Fourthly, inspect the wiring for damage. If you are not comfortable troubleshooting electrical problems, hire a licensed electrician. Electrical codes and standards are constantly being updated. It's important to stay informed about the latest changes to the codes and standards to ensure that your electrical work complies with the current requirements. Subscribe to industry publications, attend seminars, and participate in online forums to stay up to date on the latest code changes. Electrical inspections are an important part of the electrical safety process. Inspections ensure that the electrical work complies with the building codes and regulations. The inspector will examine the electrical system for any defects or violations. If any problems are found, the inspector will require them to be corrected before the electrical system can be approved. An electrical plan review is a process in which a qualified professional reviews the electrical plans for a building or project to ensure that they comply with the electrical codes and standards. The plan review process can help identify potential problems or violations before construction begins, which can save time and money. The plan review process typically involves submitting the electrical plans to the local building department or a third-party plan review service. The plans are then reviewed by a qualified professional who checks for compliance with the applicable codes and standards. If any problems are found, the reviewer will provide comments and recommendations for correction. After the plans have been revised to address the reviewer's comments, they are resubmitted for approval. An electrical load calculation is a process in which the total electrical load for a building or project is calculated to determine the size of the electrical service and equipment needed. The load calculation takes into account the lighting, appliances, equipment, and other electrical devices that will be used in the building. The electrical load calculation is typically performed by a qualified electrician or engineer. The results of the load calculation are used to determine the size of the electrical service entrance, the size of the panel board, and the size of the branch circuits. An arc flash is a dangerous electrical event that can occur when a short circuit or other electrical fault causes a sudden release of energy in the form of an electrical arc. Arc flashes can generate extremely high temperatures, intense light, and a pressure wave that can cause serious injury or death. Arc flash hazards are typically found in industrial and commercial electrical systems. Arc flash studies are performed to assess the risk of arc flash and to develop safety measures to protect workers. An electrical short circuit is an abnormal condition in an electrical circuit in which the current flows through an unintended path with little or no resistance. Short circuits can be caused by damaged insulation, loose connections, or other faults. Short circuits can cause excessive current flow, which can damage equipment, start fires, and cause electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect against short circuits. Ground fault circuit interrupters, GFCIs, are devices that protect against electrical shock by detecting ground faults and interrupting the circuit. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a risk of electrical shock. Surge protection devices, SPDs, are devices that protect electrical equipment from voltage surges, such as those caused by lightning strikes or power outages. SPD are typically installed at the service entrance of a building to protect the entire electrical system. Power quality refers to the stability and reliability of electrical power. Poor power quality can cause equipment malfunction, data loss, and other problems. Power quality problems can be caused by voltage sags, voltage swells, harmonics, and other factors. Power quality monitoring equipment is used to identify and diagnose power quality problems. Harmonics are distortions of the electrical waveform that can cause equipment malfunction and other problems. Harmonics are typically caused by nonlinear loads, such as electronic devices and variable frequency drives. Harmonic filters are used to reduce the level of harmonics in an electrical system. Power factor is a measure of how efficiently electrical power is being used. A low power factor can cause increased energy consumption and reduce system capacity. Power factor correction equipment is used to improve the power factor of an electrical system. Electrical energy efficiency refers to the amount of electrical energy that is used to perform a specific task. Improving electrical energy efficiency can save money and reduce environmental impact. Electrical energy audits are performed to identify opportunities to improve electrical energy efficiency. Renewable energy sources, such as solar and wind power, are becoming increasingly popular. Renewable energy sources can reduce reliance on fossil fuels and reduce environmental impact. Electrical codes and standards address the requirements for installing and connecting renewable energy systems. Smart grids are advanced electrical grids that use digital technology to improve efficiency, reliability, and security. Smart grids can enable features such as real-time monitoring, automated control, and demand response. Electrical codes and standards address the requirements for designing and installing smart grid technologies. Electric vehicles are becoming increasingly popular. Electric vehicles require charging stations which can be installed in homes, businesses, and public places. Electrical codes and standards address the requirements for installing electric vehicle charging stations. Electrical safety in the workplace is essential for protecting workers from electrical hazards. Employers are required to provide electrical safety training, to use safe work practices, and to provide personal protective equipment. Electrical safety audits are performed to assess the risk of electrical hazards in the workplace.